We now carry on our discussion by putting up a problem of an improper integral in which both the limits are such that the integrand becomes infinitely discontinuous at both the endpoints. So what we are talking of is something like this: a to b fx dx, where fx has infinite discontinuity at A and at B, both. Now, if we go to our line theory, A to B, both are points where there is the situation is that the function will be infinite at A as well as B. So here the trick is, as before, we start from a point that is slightly to the right of A and end at a point that is slightly to the left of B. So this is perhaps epsilon 1, a small positive quantity, and this is epsilon 2. So we integrate from A plus epsilon 1 to B minus epsilon 2. Again I repeat, we integrate from A plus epsilon 1 to B minus epsilon 2. Evidently, epsilon 1 and epsilon 2 tend to 0 from the positive side. So that guarantees that we are very much within the interval of integration and do not flow outside. That's very important. We cannot flow outside here, we cannot flow outside here. So this guarantees, this process of attack guarantees that we are not leaving the interval of integration. I will put up a very simple problem on the board and see how to evaluate it. So we rub out everything and take up an example. Evaluate 0 to 1 integral x into 1 minus x. Now very clearly at x is equal to 0, this does not have a well defined value. At x is equal to 1 also, this does not have a well defined value. So we are compelled to do the following. We write this as epsilon 1, take a point in between. Let's take a point in between. So between 0 and 1 is a point half, exactly the midpoint of the interval. So from epsilon 1 we integrate up to half, and then from half we integrate up to 1 minus epsilon 2, where epsilon 1 and epsilon 2 tend to 0 from the positive side. So that guarantees that we are very much within the interval of integration. We now proceed to evaluate this integral for, okay, we'll call this I1 and we'll call this I2. Combine them algebraically and see what happens. So let's start with I1. I1 is the name given to epsilon 1 up to half dx under root x into 1 minus x. Now we need to carry out a bit of indefinite integration. For that, we will see in 1 or 2 steps the best way of tackling this. Now, if we take this integral, it is x minus x square, that is dx over minus x square minus x, we put a 1 by 4 inside and put a 1 by 4 outside like this. So 1 by 4 minus 1 by 4 after removing this bracket is 0, and then we have x minus x square, which is exactly the integrand here. Now this is nothing but integral dx over square root of half square minus x minus half whole square. Now this is of the form a square minus h square, so the result is sine inverse x minus half over half. In other words, this is sine inverse 2x minus 1. That is the indefinite integral. Sine inverse z over a, that's perfectly all right. Now we'll have to evaluate this between epsilon 1 up to half. So that will be the value of I1. So we'll write it down separately. I1 is nothing but sine inverse 2x minus 1 limits epsilon 1 up to half, where epsilon 1 tends to 0 plus. This is sine inverse 2 into half is 1, so sine inverse 0 minus sine inverse 2 epsilon 1 minus 1. And keeping in mind that epsilon 1 tends to 0 from positive values. Now this is sine inverse 0 is 0 minus sine inverse, when epsilon 1 tends to 0 plus, this vanishes. So we have sine inverse minus 1, which is minus pi by 2. So minus of minus pi by 2, and that is nothing but pi by 2. So we trap that result as I1 is equal to pi by 2. We box it slightly here. Next is to evaluate from half to 1 minus epsilon 2. That was I2. Sorry. I2 is equal to the same integrand. I2 is equal to, from half we go all the way up to 1 minus epsilon 2, same integrand, let's say dx. This is sine inverse 2x minus 1 trapped between the limits 1 minus epsilon 2 and half. this is equal to sine inverse 2 into 1 minus epsilon 2. So sine inverse 2 into 1 minus epsilon 2 minus 1 minus sine inverse 2 into half minus 1, that is sine inverse 0. Now this becomes 2 minus 1 is 1. So sine inverse 1 minus 2 epsilon 2. This is sine inverse 1 minus 2 epsilon 2. And we take the limit of this as epsilon 2 tends to 0 from positive sides, from the positive side. So that would result in sine inverse 1, which is nothing but pi by 2. So we trap that as well. We say I2 reduces to pi by 2. So when we combine I1 and I2 to give the value of I, we come to the conclusion that our friend I is nothing but pi by 2 plus pi by 2. So 2 times pi by 2, that is pi, and this is the result. So the integral is a finite quantity, it converges to the value of pi, and that concludes this part of the discussion.